Today's topic is going to be about Riemann's sum.
The theory of Riemann sum is an approximation of the area of a certain figure or formula. The sum of that area is calculated by dividing the figure in small rectangles, then getting the area of that rectangles and then adding them all up. This theory was created by a German mathematician called Bernhard Riemann, and it's based on or focused on this formula that's written over here.
This is a clear example of how the figure after being divided on the rectangles would look like.
In order so that we can have a better understanding of the topic, I'm going to explain a little problem to demonstrate how this theory is done and solved. You need to be given a formula such as this one. That is the one you're going to be working with. Also, you need to be given a range from the x's, from which range you're going to be focused on your graph, and also a delta x, which means the range in which each rectangle is going to be drawn. First of all, to get a more visual idea, we're going to draw this graph. In this case, x squared plus 1 is a parabola with a shift upwards. So your graph is going to start here, and it's going to go something like this. Okay, now you need to label your x-axis. Since the delta x is 0.5, it goes here from 0.5, 1, 1.5, and 2. You need to have clear that there is a left hand and a right hand. In this case, I'm gonna graph or draw the left hand in a green color and the right one in a pink one. This works in a visual way, just to know that the left hand you're gonna start from this side until the right, drawing the rectangles, and the right one you're gonna start from the right to the left, vice versa. So in this case, the left one you're gonna start on the 0, which is the first part of the range. So you start here, you go up until until you touch the line, and then you're gonna make a rectangle here and go up. There's your first rectangle. Now you start on 0.5, you go up, and you do the same thing for each one of the ranges. In this case, it's going to look something like this. And the right one, you're gonna start on this side, and then you're gonna go up until until the line touches the line of the formula. And then you're gonna come to the left, go down, here, go down, and it ends up something like this. In here, we can see that you have some spaces left. Here you have like extra space, and on the green one you have some missing space here. That is why the Riemann's theory works as an approximation, because the space that is left over on the top is kind of the same as the space that is missing on the bottom, so it kind of like compensates one with another. Okay, now after you draw your graph, we're gonna be working with the left and the right hand. For each one of them, you need to make a table of values like this one. You're gonna start for the left hand. You're gonna start on the very first point you started. In this case, it's the 0. So you go from 0, then 0.5, then 1, and then 1.5. After you wrote the x values, you're gonna have to plug in these values on the formula that you're working with. In this case, you do 0 squared plus 1, it gives you 1. 0.5 squared plus 1, it gives you 1.25, and so on. After you got this table of values, you're gonna have to take out the areas. For getting out the areas, you're gonna multiply the values you obtained in y. In this case, it's 1, and you're gonna multiply it by your delta x. So you're gonna get 1 times 0.5, 1.25 times 0.5, 2 times 0.5, and 3.25 times 0.5. You multiply these and then you're gonna get your area. After you multiplied the y values times the delta y, you're gonna get an answer, and then you're gonna add up the values you got for each area of each rectangle. In this case, the sum of these numbers is 3.75, and this is the area for the left hand. Now you're gonna do the same with the right hand. You do the table of values. In this case, the x values, you're gonna go the other way around. You're gonna start with the 2 and you're gonna go backwards. You start 2, 1.5, 1, and 0.5. And you're gonna end up there because it's the last point of the line you touched. So you plug these numbers in the formula and you're gonna get your y values. Okay, after you plugged in the x-axis, the x values on your formula, you're gonna get your y values. You're gonna do the same as you did on the left hand. In this case, you multiply your y values times the delta x, and these are the values you get. Then you add them, you're gonna get 5.75. Now, for this problem, you're done. This is the two answers you're gonna get for this problem. They are kind of different because in this case, as you can see, it's a little bit bigger, the space that you have left over rather than the one you're missing. So that's the only difference, but anyway, it's a very close number between them, so it represents the approximation of the area of the space below the line you graphed. Okay, now if you want to practice a little bit, you can do this problem. It's 5 minus x squared is also a parabola but going down. You don't necessarily need to draw the graph. In the case of the previous example, I decided to graph it to make it a little more visual, just to see how the rectangles are drawn and what represented the space that was missing or left over. Okay, here's the answers for the practice problem that I wrote before. The x-axis, the same thing, you're gonna write the values you're given of the range. So you put 0, 0.51 and 1.5. Remember, you don't go till the last number. So in this case, the y values are gonna be these ones, and then you're gonna multiply all these numbers times your delta x to get the area of the left hand. In this case, the total area of the left hand is 8.24. I forgot to mention on the previous example that the units are gonna be units squared, the area for the area of the figure. For the right hand, you're gonna go backwards. You're gonna start with the x equals 2 until the 0.5. So it's 2, 1.5, 1, and 0.5. These are your y values. And you're gonna do the same thing. You're gonna multiply the y values times 0.5, which is your delta x. And you're gonna get 6.25. These two are your last answers. And here's a little visual aid for this problem. This is how it will look. It's a parabola, it's going down. Suppose that the parabola continues this way. So your y-intercept is 5 and it's going down, and it ends up 2, and this is the range you have to take in mind for this problem.